Not sure what happened.
Just remote school
Sorry we
things.
angered you, Brian.
You're too quiet.
You know, I understand that you made a lot of MuleSoft money off that video, but that doesn't mean you can just abandon us, man.
Oh, Jameson said they ended it by accident.
All right, everyone, we have to keep Jameson entertained or they will remove our ability to learn.
All right, now it looks like we've got most everybody back. So I'm gonna keep going forward with this lesson here. Yeah, let me find my Zoom window. Cool. So APIs, I'll give you this very brief spiel here. So at a very high level, APIs are what allow web applications to communicate with each other. So up until this point, we have really just been building applications with a very simple interaction in mind. And simple is a relative word, of course, but our interaction is there is a user, a human person who's using a web browser. They're visiting your website. They're interacting with your HTML links and buttons, et cetera, et cetera. They're using your application. Our app's job is to take their input and do something with it. Usually we're going to like change something in the database. You know, maybe the user clicks on a link, they want to see all of the invoices in the application, or they want to see all the items for sale. Or we retrieve those from the database, we show it to them in HTML. And that's really what we've got going on in our apps up to this point. Now what we want to start to think about is how can we leverage other applications to make our apps even better? So for example here, we've got this sentence here. Imagine you want to show tweets in your application. Well, Twitter has an API that you can consume. That would be the language. When you're using an API, you're consuming it. So we could consume Twitter's API to show some tweets. So maybe we're building like Adopt Don't Shop and we want to show tweets from like the top 5 animal shelters in Denver, something like that. Another example we have here is the Google Maps API. So you can utilize their API to embed an interactive map inside your application. I think this goes hand in hand with the phrase that's pretty common in tech, which is look for a solution before building a solution. So you could build out your own interactive map platform, but Google Maps already offers that. So rather than building it out yourself, you can just utilize their application that they've already built. So once applications start leveraging other applications, that's where the internet becomes really powerful. To kind of give you a visual demonstration, I'm going to draw on this whiteboard. So if I draw like kind of my normal client server interactions, I'll draw this pretty often here. So I'll say like we've got a client on the left here. Let's draw a server on the right. And so user using their web browser, it's actually labeled these. So this is a client. So this is a web browser. They're going to send their HTTP request. Our app is going to receive that. So we've got a running server over here. We're going to receive that. Usually we're going to have to interact with a database somehow. So maybe I'll draw it like this. So this will be our database. And we might need to retrieve things or send things off to the database, and we'll get that data back. And then somehow we'll create a response to this user's request. So then we'll create an HTTP response. And this response is going to include typically HTML, and we'll say HTML and CSS. And so that's what the user sees, and that's what their browser displays. As we are starting to think about APIs, we want to leverage other applications. So for the example that we had in that lesson plan, maybe I'll use a different shape here. Let's use a circle. There is out on the internet, maybe there is this Twitter API, and then maybe there's also a Google Maps API. And so now our app is also going to communicate with those APIs to get some additional data. So as you see me draw this out, you can see that it's very similar to interacting with the database. So in the same way that our code interacts with a database to get some data, very similarly, we can interact with an API to get some data. And in the same way that we can send data off to our database, say, hey, we want to create this new item, or we want to create this invoice, or we want to update this merchant. We can also communicate with the APIs. We can say, hey, Twitter, I actually want to send out a tweet. So Twitter's API will allow you to read tweets, but also send it. Yeah. So that's kind of my spiel here. What questions do you all have? Alex?
Do we communicate the same way? Like, do the asks, when we talk to the server, did we talk to the API like through the server, but like in the same way with the same syntax, or am I just way off?
Yes, very, very similarly. So if all of the space in this diagram, all the space in between the boxes, so if I just kind of scribble like all of this space out here, like around the boxes, and all of the space around here where the arrows are going through, that is like the internet. We're sending requests through the internet. So let me just undo some of these scribbles. Maybe if I draw them a little nicer, like I'll try and draw some clouds. There's some clouds around here just to indicate our requests are going through the internet. If that is true, we're communicating in a very similar way. We are sending HTTP requests and receiving HTTP responses. So notice how our app is receiving requests, but now that we're communicating over the internet with these APIs, we're also sending requests. So your app can both send requests and receive requests. So we're actually doing both. Our server is, in a sense, a client when it comes to the APIs. That might be a little bit too much for right now. I do want to get into some more HTTP specifics in the follow-up class that we'll have next week. But yes, very important to point out, we're still in the land of HTTP. Natia.
Can you speak to, and sorry if it's kind of like black magic, but like when the data gets picked up, where does it get put in the database? So like, do you have to have a table structure ready for it? Or can you consume it without the database, like capturing it? Like, do you have a choice?
Yes. So what we'll do next is we'll look through a code example that's just really simple, like grab some data from the Github API. What you do with that data is totally up to you. You're the developer, you're writing the code. So you determine, now that we have that data, what do we do with it? The process is going to be, we're going to consume these APIs in Ruby. So that data is going to be stored in our Ruby programming language, but that Ruby is temporary. That is technically it's in memory. It's using up your RAM, so it's not permanently stored. If you want to store it in a database, you totally could. So for example, if you wanted to store a database of, you wanted to have a table of tweets so that you could store like the last most relevant tweets on a given topic in the last 100 days or something. You're kind of like storing a subset of Twitter's data. So Twitter keeps track of all tweets. Maybe you in your database, you want to keep track of like the most relevant tweets for your application. So the answer to your question is you can do whatever you want with the data, including storing it in a database table. And some of this should become more clear as we get some more hands-on practice. But yeah, what other questions do y'all have right now? I'll go ahead and click save on this diagram just in case we want to reference it later. Lawrence?
So I was looking at some of the API building. Is that, so it's passed in JSON. Is it typically written in Java, or is it, do you have a lot of experience with APIs, or do they get thrown together in all kinds of languages?
So they get thrown together in all kinds of languages. And because we are communicating over the web via HTTP, we have to be language agnostic. There are apps that are written in the Python Django stack. There are apps that are written in the LAMP stack. There's apps that are written in just pure PHP. There's like a web application and an API is a type of web application. They can be written in all kinds of different languages. What we need to make sure is that we have a language agnostic means of communicating. So HTTP is one of those ways that we do that. And the second piece there is JSON, which we'll talk about next. So let's go ahead and talk about JSON. So back over here at my lesson plan, just to wrap up with this section before we move on to the JSON section. So when we talk about APIs, API can mean a lot of different things. When we talk about programming languages, we could say that those languages have an API. RSpec, for example, I would say you are using an RSpec API. So API can have a lot of very broad contexts. Know that when most people say API, they're talking about web APIs, which is kind of that diagram that I was just drawing for you. So they're talking about communicating over the web, over HTTP, those types of APIs. So yeah, this last bullet here says, because we're working on the internet, all web apps, we have to communicate in HTTP. APIs, more specifically, the format of HTTP requests and response that they can accept. Jen.
Just to kind of fill in the gaps, can you explain to me why you wouldn't just call an API a database, like what it does and doesn't have compared to a database? Like I'm getting it, but just like the definitive bullet points so that I can kind of like have it sink in. Yeah,
I'm gonna go back to this diagram for that. So very, very similar ideas. Accessing an API is usually part of that is you're accessing a database. So let me actually do this. Let me draw this first and see if this makes more sense. So let's say there's another database over here. And maybe I'll just label this one. This is Twitter's database up here. And Twitter's API has access to Twitter's database. So what we can see in this diagram is we can see that we can access from our app over here. So this server, this is what we control. This is our Rails code right here. We can access Twitter's database through Twitter's API. So we talk to Twitter's API talks to their database. Why do they do that? Well, Twitter can't just give us direct access to their database. If people had direct access to Twitter's database, that would be very bad for them. So Twitter's API is kind of like the gatekeeper to their database. It's like sitting in front of the database right here saying, here's what you can and can't do to the database. Oh, you want to retrieve this information? You're allowed to do that. But Twitter's API is not going to let you just delete all of their users. They're not going to let you delete all of their Twitter profiles. Going back to the video with the waiter example, it's kind of like how if you're a customer at a restaurant, you can't just go back and talk to the chef. You can't just tell the chef exactly what you want. You have to talk to the waiter, and then the waiter talks to the chef. And there might be some more steps in between, but at the simplest level, that's what it is. The waiter is making sure that they are relaying what you want appropriately to their chef. In very similar to this example, the chef kind of controls what you really want, which is the food. Twitter's database is what we really want. That's the data, but we have to go through the API first.
Can I ask a follow-up question then?
Yes, please do.
When you, I don't know if it's buy or acquire an API, is it kind of across the board what's limited, or does each provider, I know it's not the right word, define like what you do and don't have access to, and then that's brought up to you when you acquire that?
Exactly. So you're saying acquire an API. I might say you pay for an API. So you can think of this API as a service, and yes, each one tells you exactly what you can and can't do. Most APIs have like a free tier where it says you can access this stuff. And usually there's rate limits associated with, so it's also how often you can access it. So it's not, you can just constantly hit this API over and over again, because that does take computational power. So usually they'll give you a free tier, which is like, you can access it this often. But most APIs also have some sort of paid access as well. So if you are a big company and you're really trying to use this data extensively, you'll usually have to pay for another tier up, which is like, okay, now you have access to more data and you can access it more often.
So can I ask a follow-up question?
Mm-hmm.
Would it be like if I was standing in a room that's just a circle and there's like doors all around and every door is locked, but once I pay, that door opens, that's the API, but I can only really communicate with like the front desk person and whatever they decide I can have access to. Like that's, so I have access to the database through that, but only what they're allowing.
Yeah, if I just take the one part of that, the front door, so like you go to a bank, for example, and you can't just like go back to the vault and get whatever money you want. You have to talk to the teller, and the teller is going to tell you what you can and can't do. And if you say, well, I actually want to take out a loan, they might say like, oh, well, actually you have to go through this separate process to do it. But still, there's like the teller is like the API. There are people that you have to interact with to get to the money. Does that help?
A lot. Thank you very much.
You're welcome. Regina?
Can you use PayPal as like an API?
Yeah, that's a really good example. I think Stripe is a more common one, which is used for like credit card payments. But yes, that's a great example of look for a solution before building solution. A company like PayPal or Stripe has already written all the code that you need. They've created the tools for processing payments. So rather than you kind of like reinventing the wheel and writing your own payment processing system, you can just use their API to process payments for you. So your app might take in credit card info, but then you send it off to PayPal for processing.
Okay, but and like most of these like cost to like use them. I'd be like curious if like those like APIs would take like a percentage of sales. Do you think?
I don't know about that for like payment processing ones. Yeah, I don't know. I'm not like financially savvy enough to really have an answer to that. I wouldn't be surprised though, if it's like the X percent rather than like pay for access, it's like X percentage of transactions. Zach?
Thank you.
So just to jump on to Regina's point, I think you're thinking about two different things when you're talking about like percentage of sales. Whenever you basically like whenever you run your card, people like Visa or MasterCard, they're the ones that are taking that cut. That kind of has nothing to do with you interacting with their API. It's just more of cost of doing business in general.
Got it. Yeah. So every credit card transaction, whether it's through like a swipe machine or online or through like a third party, every credit card interaction already has some sort of like fee on top of it that the credit card company is taking.
You'd pay that, but then you pay your API separately, probably. Okay, that makes sense.
Probably, yeah. I would say the most common paradigm for APIs is there is a free tiered access where you can really like develop with the API. So for our purposes, free tier is usually fine. It's just once you start needing higher and higher volume. So for instance, I need to hit this API 10,000 times every hour. Once you start getting into a higher volume, that's when you need to start paying for things, or for like just like more unrestricted data. Jen.
I'm probably jumping ahead, but I would imagine that you are not accessing APIs in the same way that we use like MVC and routes, that there'd be like a whole other component to our code and app.
There is another component to our code. And
Okay.
the component, if I'm relating it to this diagram, is really this part right here. Can I make it blue maybe? I'm gonna try again, I'll make it blue. This part right here, the HTTP requests. So up to this point, Rails has built in structures for receiving the requests and sending the responses. That's kind of what it does. We don't yet have the tools to send the requests, and that's what we're going to do next, which is Faraday. That is the tool we need to use.
Thank you.
Let's get into that. Yeah. So I guess the first thing here we have to talk about is JSON. So up to this point, we've been talking about like humans using our application, and so we need a human readable format. So for humans, we want things to be visual. We want to see them and interact with them. That's where HTML and our CSS comes in. So when we're writing HTML and CSS, we're thinking about people looking at it and it being visually usable. Now that we're talking about applications interacting with other applications, we now need a way for them to be machine readable. So JSON is this kind of agreed upon, it's an agreed upon standard. So JSON stands for JavaScript Object Notation. JavaScript is a very widely used programming language. So the JavaScript Object Notation is also very widely used. If we take a look at some of these examples here, and this one, if you click on this, you'll actually have to scroll down. Let me do this actually. If I click on this one, we can see an example of JSON. Maybe let me zoom in a little bit. And what you'll notice is that it looks very, very similar to our hash notation in Ruby. So if a hash is a data structure for storing key value pairs, this JavaScript object notation, JSON, does exactly the same thing. So it follows very similar rules for our hash notation, which is it starts with an open curly bracket, and then it has key value pairs. And the key value pairs are separated with this semicolon. Unlike a Ruby hash, JSON does require that the keys are, I believe the keys need to be quoted. But now that I'm saying that, I don't think that that's entirely true. Not super important either way. The key things I want you to take out of this are key value pairs, and they're separated by this semicolon. If we look at another example, if you click on example 1, you'll have to scroll down a little bit further to response. But we'll see, and this is the GitHub API's response. We'll see another example of this. And what this one illustrates is this idea of nesting data structures. So in the last one, we just saw one big hash. This one we can see, and I'm even referring to it as a hash. We can see this big, what looks like a hash, which is really a JavaScript object. But then we can see some keys which are pointing to other JavaScript objects. So this is kind of our nested collection, our hash within a hash. We can also see an example of an array. So we have arrays in JSON as well. So it looks like this key is parents, and that points to an array. And this array, it looks like just has one parent, but this is maybe if I think this is for commits. So this is like if multiple, there were multiple parents for one commit, maybe it was like a merge commit, there would be multiple in this array. So very, very similar to what you all know about hashes and arrays in Ruby. And then I would also recommend that you install this Chrome extension for JSON formatter. If I go back to this example 2 here, I'm clicked on JSON formatter, gives you these raw and parse buttons. So raw looks like this, which is a little bit harder to read, versus it gives me access to parsed, which is really nice. And I can even like collapse things as I need to as well. So I would recommend you install JSON formatter. There's other extensions that do something very similar. All right. The next thing that I'm going to have you all do is play around with this. So there's some sample code right here for this is I want to see some code you right now. I'm done listening and talking about APIs. So this is what I'll have you all do next. Maybe before we go too far in that, does anyone have any other questions on JSON? All right. Well, I'll let you all go ahead and keep working through the lesson plan wherever you're at. If you didn't get a chance to read through this section, I would just recommend you read through these and then get into APIs in action. We'll do something similar here. We'll come back together at, let's plan to come back together at 2:30. So we'll come back together at 2:30. And if you have time, try to get into some of these give it a try sections and even get into some of these practices. So once we come back, I will kind of work through these parts that don't have a sample code to it. And we'll talk through some of these checks for understanding, and that'll be it. We'll come back together at 2:30.
Brian, do you mean 3:30?
Oh, yeah, 3:30.
Okay, good.
And I'm going to write up those instructions and put them in your cohort channel so you can reference back. I just dropped these the instructions in the cohort channel, but I did want to mention here, if you run into any issues while you're working through the code, just let me know and I'll be happy to assist.
Hey, Brian, I'm getting an error that I'm not sure how to fix.
What is that error?
Here, I'll share my, I can't share while you're sharing, but it is
Am I still
missing.
sharing?
Yeah,
There we go.
so this error.
Oh, wow. And how did you produce that? What was the command that produced that?
Just trying to run the Ruby file.
Okay. So I think did you do gem install Faraday?
Mm-hmm.
Can you run that from the command line? And let's see what that does.
Gem install Faraday.
Yeah. Okay. So that looks like it worked. Can you run your Ruby file one more time? Interesting. Missing EM synchrony dependency. And is this? Yeah, and I can see in that stack trace, I see some mention of Faraday. Can you do gem update Faraday maybe?
I had a similar error and I had to just change the folder I was in because it had some leftover gems from something and start fresh, and then it worked. But
I'm just in an empty file.
What can you do a Ruby -v from here? Let's try gem uninstall Faraday. Let's just reinstall it. Let's try it again, see what happens. Yeah, interesting. Let me see on my end what I will get. Yeah, let me try it. Okay, so mine installed that same version. I think mine is Mine seems to be working, I think. Can you do a gem list Faraday? Can you scroll to the top of that stack trace?
Yes.
So this is just when you are requiring the library on line 1.
Mhm.
So cannot load such a file Faraday. If you go all the way to the bottom, I think it had it says like missing synchrony dependency gem install. Can you copy that gem install em HTTP requests and just run that from the terminal? Okay.
Okay. That
Great.
worked.
Well, I guess that works.
Thank you very much.
You're welcome.
Brian, just a quick question. Like, I see what this is doing. What is the purpose of this particular API?
This particular API, if you're referring to the GitHub API, it's any data that you want on GitHub. So maybe a better, the purpose of the GitHub API is very vast. Let me see if I could just go, if I just Google GitHub API.
Well, because it had me put in my username. So I put in my username and it's giving me all my information, right? So I guess this particular one with like my name on it, I guess, like would be the purpose of it, I suppose.
Oh, yeah. Well, so your project should give you a little bit of insight into that, to where you are going to be consuming the GitHub API on that project. So the way we're going to use it on the project is to just get like information about the project. So we'll have you do things like list how many commits have been made to this repo, list who are all the collaborators for this repo. I'll use the term endpoint. So the one specifically with your username in it. That's really just data specific to your user. And I would say the point of it is look at all the data. The point is to get access to that data. So anything you can imagine you could do with that data, that's the point of it. And I think some of those pieces of data even link to other endpoints in the API. So one of the purposes of that is to like link you to other things.
So does an API only give data?
You can also send data to the API. It depends on how the API is built, but you can do things on GitHub, like you could merge a pull request on GitHub, and that would probably be like a patch request or something. Let me just let's do a quick perusal of these API docs because I've got it up here. So reference, we can do, let's go to repositories here and just look at all the things that we could potentially do over here. So you could create an organization repository, you could update, you could delete a repository, you could transfer of repository. So you could write a program that takes all of your repositories and transfers it to someone else. You can delete a pull request. You can, so really like this API is very large and you can do a lot of different things with it.
Okay, thank you.
You're welcome. Alex?
Yeah, I was wondering, in the directions it says like, now you know what's happening, try to refactor stuff. Maybe I missed this part of the lesson, but like, what are we refactoring? Like, I'm in the pry session and the stuff that I copied and pasted doesn't seem like it's that big where it would need refactoring, or just like, maybe I'm just like missing the point, like the stuff that we have copied and pasted, like the 3 lines of code. Yeah, that.
Yeah.
What, you want to give me like a hint of what we could refactor? Like,
So I think the first step is like just copy this code.
yeah,
And then I
yeah.
think the second thing is implement this one little piece of code. And then it's kind of like from there, try and do these 3 things.
Got it.
So maybe just write like some put statements to say like print out your number of followers is, and then your number of followers. The date you joined GitHub is this.
Okay, that makes sense. Thank you.
And then once you do that, you'll probably have something that you can refactor.
Okay, thank you.
You're welcome. Sid, I see you posted something in the chat. Did you get your error figured out?
Yeah, I don't know exactly what I did wrong, but I just copied the prompt instead of typing it out, and it worked.
Okay. Richard.
Regina said something about the GitHub API. I just wanted to shed some light on some of the usage. When I interned at Workiva heavily uses GitHub, and there are literally hundreds of repositories that they have, hundreds. And so there's like just more than hundreds of branches and commits. It's like unbearable. So they use the Google API to pull their own statistics into a more readable, manageable way so that they can understand what's going on, where are these pull requests, like how many pull requests total are currently happening, rather than going through every single repository and counting by hand all the pull requests.
Thank you, Richard. Yeah, I think that's a great example. Too many pull requests to just like look at by hand. Let's use the API and write a program to report out to us.
Do APIs, are they typically like 1 line of code? Well, minus the requires.
Yes, I don't. That's a tough question. Like, is it typically as easy as 1 line of code? I would say no. Actually, so I'll reverse my answer. No, I think a lot of times there are other things that you will want to include. But I think for right now, we're trying to keep it as simple as possible to really focus in on the idea.
Thank you.
You're welcome. I'm going to step away for 5 minutes, and if anything comes up in that time, I'll I'll be back at 3:20. All right, we've got about 5 more minutes until we come back together. If you haven't already and you would like to take a palm, this would be a good time. We're gonna come back together at 3:30. This is your 1-minute countdown until we come back together. All right, everybody. So I'm going to go over this this activity and just kind of talk a little bit more about APIs. So if you have questions as I go, please feel free to use the raise your hand button, and I'll get to you. So the first thing I want to do here is I've just copy and pasted the starter code in here, and the first thing that I'm going to do is I'm going to change this your GitHub username. I'm going to change this to my username. So I'll change this to Brian Zanti right here. And I'll go ahead and run this code. So I'll run, I've called this file APIs.rb. And so I can look at my body right here. And here is that JSON hash that we're talking about, or it kind of looks like a hash. But by default, this is just coming across as a raw string. We can see this whole thing is just one big string right here. And so if I go back to the lesson plan, it talked about this json.parse command right here. So I can take that and put it into my pry session. And I'll see that this looks more like the hashes that we all know and love. This has the curly bracket here, and it has key value pairs, and they're separated with this fat arrow right here. That's just how it's going to be represented in pry. So I said before, JSON is a language agnostic way of communicating. So essentially, GitHub's API, written in whatever programming and language it might be written in, it sent us over this raw string, and our Ruby programming language is easily able to convert that into Ruby by this json.parse library. So this just kind of shows you how built in this is into a lot of programming languages. Ruby comes with this JSON library for parsing JSON. So it's very easy. So I'm just going to take this and drop it into my pry session or my Ruby file here. And I can save this as a variable. We can call it JSON. And something else that that wasn't mentioned in the lesson plan, but I think is a nice option, is to add in a second keyword argument here for json.parse, which is symbolize names true. So I'll go ahead and put a pry right below that and rerun everything. And now I'll see what that JSON variable is holding on to. And you can see what the symbolized names true does. It turns all of your keys into symbols. So now rather than string of login, I now have a symbol of login. So that's just an extra option that I think makes this slightly cleaner as I'm working with it. Working on the next part of the, I'll just go ahead and copy and paste this. So the next thing that it asked me to do is find the number of followers, the date you joined GitHub, and find some data of your choice. So looking at this big JSON hash, let's find, I see followers URL here. This is going to point me to another API. These are called endpoints. So each different thing you have access to in the API. So this is a user endpoint for one user. So it looks like followers URL links to another endpoint. Is there just like a number of followers in here? Oh, there it is, followers. So I see I have this key of followers and it points to my followers. So I think the way I would access that is JSON and then hash syntax followers. Cool. So I can take that and put that into my Ruby file here. And then I could say something like, let's just print it out and let's interpolate it into a string that says number of followers, like so. So now if I take out my pry, oops, and run this again, hopefully we'll just see that printed out. And there it goes. It says number of followers 31. So finish this one. The date you joined GitHub. Let's put that pry back in and look at our hash of data. and see if we can find the date we joined GitHub. Created at, that's probably it. Yep. Cool. Okay, so I think very similar. I'm just going to copy this line of code, and I'll just copy this key of created at, and I'll say date I joined GitHub is this. And let's pick out one other piece of data. Let's say, oh, I don't know. Let's just pick up name. Let's do two of them. So I've got my name and I've got my login here. So I could say something like, let's print out, I don't know why I copied that. Let's print out login name is Json login, and display name is Json name. And let's see if that all prints out. And there we go. Looks like it's printing out just what I want to. So there we go. Now we're at the point in the lesson plan where it says, congratulations, you just consumed an API. So that was really it. In terms of just like conceptual understanding, that is all there is to consuming this particular API. So just to kind of recap, we use this Faraday library to send our HTTP GET request. We specified this URL, which points to GitHub's API. That API received our request, returned a response, and we saved that into this variable. The data was stored in the response's body. We'll get more into the HTTP specifics next week, but we had to pull the data we wanted out of the body. We used this built-in Ruby library to parse that JSON into a Ruby object, which was a hash. And we processed that hash. We pulled out some data from it, and we printed some stuff out. What questions do you all have up to this point? Natia?
So I could not figure out how to mock and stub this like the instructions said, and I feel like that's a little bit off topic, but is there any way at some point we could do that?
Yeah, let's hold off on that for now. I do want to go through these practice exercises, and I'll try to like go through them in order. Jen, does that get to your question as well?
No, I was debating on asking it. I'm assuming then when we do this, if a value changes, it will automatically update through there. Like if your followers went up to 45, would it automatically update, or would you have to add something?
It will automatically update, and that's another reason we would use these APIs, is because this is real-time data. I'm trying to think of something that we can do that. Let's see if we can do that with number of, let's actually do number of following, because I can change that easily. So let's also add in number of followings. And that one looks like it's also 31. So if I go to GitHub, and how can I do this? Profile? Here we go, following. I'm gonna unfollow Chris. And this might take
did you want to share your screen?
Yeah, can you all not see this?
I can see it.
False alarm, false alarm.
No worries. I did that to Jameson earlier this month, I think. Yeah, so it's not updating right now. And I think this might take a minute to update. We can even see on GitHub's end, it still says 3131. So let's wait a couple minutes and we'll see if that updates after a while. Regina.
I guess I could try this on my own, but what is the security on like changing information? Can you not change it from the API? Like let's say I wanted to change the username.
Yeah, it would be very similar to what you can do on GitHub. So for example, you can't edit my profile. I have to be logged in to edit my profile. It would be very similar when you're using the API. You would have to authenticate to say who you were. And if you authenticate, then you can, you have permissions, whatever your user has permissions. So for example, your users still don't have access to the Turing School examples repos. You have access to your personal repos, but not the Turing repos. Yeah, and again, authentication is going to be a topic of mod 3, so we're not going to get into that this mod. Let me run it again and see if it changes. Still hasn't changed. It still says 3131 over here.
Chris isn't going down without a fight.
Nope. Definitely not. Okay, well, let's get into some of the other stuff here. So this first thing here says, we almost always want our code to be wrapped in classes and or methods so that we can reuse it. Refactor your code to include at least one class and one method. Feeling good about that, try to include 2 or even 3 classes and multiple methods inside those classes. So yeah, let's do that. So I think the first thing that I could do is really just like wrap all of this in one class and one method. So I could say, let's just say class API, something very simple. And let's make a method, let's just call it run. There we go. So now I've got one big class, one big method. And I define this as an instance method. Let's actually just call it a class method. And then what we could do is we could call down here API.run. And it should just run this whole method. So let's see if that works. And there we go. It's still doing the same thing. So very, very simple refactor here. I just wrapped everything in one class and one method. Let's try to do another refactor here. I'm going to try and move this into another file. So let's create some folders here too. Let's make a lib folder, and let's do that. We'll make a lib folder, and let's also make a new file in here. What do I want to call this? Let's just call it api.rb. And I'll split the screen here. And let's just take this whole class and move it over. And I think including this, all of these requires as well. My rule of thumb is if I have requires, I want them to be wherever I'm actually using the thing I'm requiring. So for instance, Faraday, I'm using that over here. JSON, I'm using that right there. Pry, I could probably take out and put that over here. And so now I would want to require ./lib/API. And it looks like that is still working. Cool. So I'm going to follow that, pattern, and I'm going to make another file here called GitHub service. So I wanted to give you all a chance to try to do some refactors on your own. Typically, there are some patterns that come with come with refactoring API consumption, and this is one of those patterns. So a lot of times when we're consuming APIs, we will have a service class. So a service is typically a class that just interacts with an API. So I will, let's make this def. So I want a method here that will just do essentially, that will do this part, which will hit the API, parse the data, and return our JSON hash. So let's take that, move it over here, and maybe let's call this method def user info, something like this. And end it. And so then, so this will just return this JSON. So I don't need a variable here. I can just parse it. So I've got this service class. It's got this method here, and it is hitting the GitHub service, parsing, pulling the data out of the response body and parsing it. So then in my API class over here, I can now say, and let's make this a class method as well. I don't think I'll need an instance. So over here, I should be able to say JSON equals GitHub service dot user info. And so now that I'm referencing GitHub service over here, I'm going to require that ./lib/GitHub service. So let me split the screen with all three of my files here. And there we go. It is, looks like it's still giving me the same data. We could make this even more flexible here. So right now, user info, I've just hard coded in my username of Brian Zanti. I could just have it take in a username. And so rather than having this hard coded, I could interpolate that username in there. And so then when I call user info, I'll just pass in my username and it should interpolate that. And it looks like that's still working. Okay, so what do I want to do next? There are a lot of ways that I could refactor this, but I think this kind of like gets you started on the idea. I want to switch gears and talk about testing a little bit. And here's where I'm going to need y'all's help a little bit, because I think you have a little bit more experience with RSpec testing outside of Rails apps. So I think the first thing I need to do is make a spec directory. And I'm going to test one of my classes. I'm going to test this service class. So inside spec directory, I'm going to make GitHub service spec.rb. And then I'm going to try to run rspec from here. And it said it didn't find any examples. So let's just look at the class and the tests. So I think I'm going to need an outer rspec.describe block here. And I'm going to need to do an end. And it returns the user's data. So let's say GitHub service.userinfo, pass in my username. And let's say JSON equals that. And then maybe can I expect JSON to be a hash? Can I do that? Uninitialized constant GitHub service. So I think I need to require this file over here. So let's require ./lib/GitHub service. And then uninitialized constant GitHub service Faraday. This is what I said before. I want to have my requires where I actually am using the thing. So because I'm now using Faraday and JSON over in this file, I think I want to move those two requires over there. Oh, and that worked. Cool. Okay, so I have just written my my first test for this GitHub service. I could probably do some other things, like if I pry in here, whoops. I think I also need to require pry because I'm not in Rails. And I look at what my JSON is returning. I could test other things of this. So I could say like, I could probably say like whatever keys I really care about. I could say maybe like expect JSON. Actually, could I say this to have key of login? I think that might work actually. Let's try that. Yeah, I think that worked. And then if I just like make a typo in here, does that fail? Yes, it does. Cool. So I think this is a good way to test it. So then I think I would just say all the things that I need, which if I go back over here, I'm looking at followers, following, created at, login. So I'll just do all those. Followers, following, login, name, and then I think created at was the other one. And there we go. All right. So the last topic that we're going to talk about here, well, the last two topics we're going to talk about are rate limiting and mocking and stubbing. So rate limiting, I mentioned this earlier, but most APIs have rate limits, which means that you can only hit the API so often. The reason for that is if there was no rate limiting, I could just like send requests repeatedly to GitHub, like in my, I could just do this. I could just say 1 million times do, and just like run this thing over and over. So with just like 2 lines of code, I would really be overloading GitHub's API. They don't want you to be able to do this. Or if you do need to do this a lot, they want you to pay for it. So most APIs include some sort of rate limit. For GitHub's API, unauthenticated requests are 60 requests per hour. One of the ways I can check that is if I go back to my pry over here, and I look at the data that's being returned. Actually, that's not going to show it to me over here. Let's put the pry over inside the service class. And if I look at response.headers and scroll all the way down, response.headers, we'll see, again, headers is something that I'll talk about in the follow-up class. But for now, it's just like another place to store data. I can see rate limit used is at 20, and I can see rate limit remaining is 40, and my rate limit is 60. If I exit out of my pry and run my test again and do the same exact thing, response.headers, scroll all the way down, we can see I've used another request. I went from 40 to 39, and now I've used 21. So essentially, if I ran this test 39 more times, I would have to wait another hour before I can run my tests. And if I have many tests that each one hit the API, for instance, maybe I hit it 10 times over the course of running my tests, that means I can only run my tests 6 times before I'm out of rate, or before I'm out of API requests. So that would not be great. So the way that I'm going to recommend that you all get around it is to implement mocking and stubbing. Can I get someone to volunteer? What were some of the things you learned about mocking and stubbing in Mod 1? Maybe more specifically, like what methods did you learn about that can be used for mocking and stubbing in RSpec? Lawrence? Oh, you're on mute. You're still on mute.
Sorry, I talked over you and didn't hear that I was on mute. We mostly learn to use doubles, set those up and allow them to receive the method calls, and then tell it what to return in the case of that method call.
Gotcha. Was part of that allow or allow any instance of?
Yep.
Gotcha. Okay. Just wanted to check in there to see what you all had covered. So I'm going to use what you all used in mod 1 to mock out these APIs. So this is a great example of an external dependency. We are dependent on this GitHub API to be working. And so I can use mocking and stubbing to remove that dependency. So I could say something like allow, let's say allow Faraday dot to receive get. And then I could also say dot with like an argument here, but I'm not going to do that. And return, can I give it an empty hash? And I hit my pry. Let me take out that pry. And I don't think that's quite working the way I want it to. Yeah, let's actually mock out our GitHub service here. So can I say allow GitHub service to receive user info and return an empty hash? No, that's not quite working.
I think you have to move the call to GitHub service below the allow, because basically you're calling and then stubbing it.
You're right. Yep. So because I'm calling it first, yeah. So let's try this. And I really want to see this fail, because if we're returning an empty hash, that should just not work. There we go. Okay. So I think I actually do want to do Faraday to receive get and return. Yeah, I think mocking Faraday is probably not a great idea. Yeah, okay. So now I think what I can do here is if I just, let me comment that out, pry in here. Undefined method pry for binding, let's require pry. Let's see what the API is returning. And this might be kind of hacky, but I'm just going to take this as my mock data. So I could say here, mock response equals this big old hash. And maybe with a little quick formatting magic, lines auto indent, make that look a little better. Now I can say, allow any instance of my GitHub service to receive this method call and return my mock response. And there we go. So now it looks like it's working. And so now I'm running rspec over and over and over again. And let's take out the mock there. Let's put the pry back in to our class here. Let's also require pry. And let's check in on our rate limiting again. So let's do response.headers. And we'll see we're only up to 33. So I was hitting rspec like at least 5 times. And I've only, I'm up to 27 right now. So if I comment out and allow any instance of GitHub again, and just hit rspec maybe 5 more times. So that 27, let's take out the mock, take out the pry, look at response.headers. And now I'm only up to 28. So this is going to be my recommended strategy for you all in terms of writing your tests. There are a lot more refactors that we can make here. And there's also a lot more that we can dive into in terms of HTTP and how these APIs are working. But for now, I wanted to like give you all kind of the tools that you'll need in terms of Faraday and RSpec mocking and stubbing to be able to implement this on your project. And then we'll follow up next Monday and we'll talk about this some more. So I'm gonna have to wrap it up here. Thank you all very much for your time, and we'll see you tomorrow.